This is a video for test 4 of the semester. I chose one of the review problems from page 779. And the directions are to figure out if the series is convergent or divergent. And the problem is sum from 1 to infinity of n cubed over 5 to the n power. So you have to choose a method to find whether it's divergent or convergent. And this one, because I see the 5 to the n power, I immediately think that the ratio test is a good option. So the ratio test definition is the limit as n approaches infinity of a n plus 1 over a of n, absolute value signs. A of n is n cubed over 5 to the n. So knowing that, we just do as the definition says to do. So the limit as n approaches infinity, the absolute value of n plus 1 cubed over 5 to the n plus 1 times, this is just a shortcut for doing a to the n plus 1 over a to the n, because we know that we're going to have to take the reciprocal when you have two fractions divided by each other. You know you have to take the reciprocal eventually, so just doing that instead of writing it all out like that, just a little shortcut, times 5 to the n over n cubed. And look at that, you see that things can cancel out easily and simplify a little. Five to the n plus 1 just simplifies to 5 to the n times 5. Then times 5 to the n over n cubed. And the 5 to the n's cancel out. Just bring my work over here. Limit as n approaches infinity of n plus 3, n plus 1 to the third power over 5n cubed. And when you plug in your infinity, you'll get infinity over infinity, which is inclusive or inconclusive. So if you do L'Hopital's rule, and L'Hopital's rule says that you have to take the derivative of the top and the bottom. Limit as n approaches infinity of 3 times n plus 1 squared over 15n squared. And when you plug infinity this time, you still get infinity over infinity, inconclusive. Do L'Hopital's again by taking the derivative of the top and bottom once again. You get 6 times n plus 1 to 1 power over 30n. Which still gives you infinity over infinity when you plug in infinity, which does not work. L'Hopital's one more time. The limit as n approaches infinity of, well, this is really just 6n plus 6. So by taking the derivative, you get 6 over 30. And when you plug infinity to this, there's nothing to plug infinity into, so you get 6 over 30 which is also just 1 over 5, which is less than 1. And the ratio test says that if it converges to a number that is less than 1, then it's convergent. If it converges to a number that's greater than 1, it'll be divergent. And if it converges to 1, then it's inconclusive. You need to try a different test. But this one, 1/5 is less than 1, so we know that that's a convergent test. So we say as n equals 1 to infinity of n cubed over 5 to the n power is convergent by the ratio test. There's the answer. That's convergent.